chapter 3 of your complex number. Okay, this section deals with the loci of the points represented by a complex number. And the first, of course, the syllabus includes the geometrical effect of addition, subtraction, multiplication, and of course division of complex numbers. So this is the first section that I'm going to go through right now. Okay, when it comes to addition and subtraction of complex numbers, all you need to remember all you need to do is to add the real part together, add the imaginary part together, or subtract the real part together, subtract the imaginary part together. So in simple terms, in your layman language or in relation to your other topic, it's basically a translation. Okay, translation of the relevant units in the positive real axis as well as the translation in the imaginary axis. Okay, and for multiplication or division of complex number, it is the same as your stretching followed by a rotation. How we visualize this concept is basically you look at your properties that you learn in your chapter 2. When you multiply two complex numbers together, the modulus get multiplied together, and when you divide complex number, the modulus or the magnitude gets divided together. Similarly, for the argument, when you multiply them, it is the addition. When it comes to division, the argument is the subtraction. So simple link will be is actually when you multiply z1 by another complex number z2, it is actually stretch in a certain direction followed by a rotation anti-clockwise, okay, with the relevant arguments. When you divide, okay, it is also stretched by a factor of 1 over z over 2 followed by a clockwise rotation about the origin. Okay, so some example to run you through. The first example you have is that if I have the complex number a, okay, if this represent complex number a and this represent complex number b, so what do I mean by az? So for example, point P is this position. Az is a multiplication of two complex number. In your simple graphical language, it is actually a stretch followed by a rotation, okay, an anti-clockwise rotation. This is a multiplication. So what is the stretch factor? Okay, you focus on your half down here. So it's stretched by factor half, meaning the length of OP must reduce by half. Thereafter, because it's multiplication, it is an anti-clockwise rotation by 5 pi over 7. So from the original pi over 4, I need to turn 5 pi over 7 over here. And this will be your eventual outcome. So when you actually draw your complex number, what you must watch out for is the length of OQ is actually half the length of OP. And then this eventual angle, okay, is pi over 4 minus 5 pi over 7. The next example is BZ, multiplication again, so it's a stretch followed by a rotation. So the stretch factor now is 2. So what it means is the length of OP must double. And then you look at the argument, it's a negative argument, so it will be a clockwise rotation by pi over 5. So what you're going to do is basically you need to double the length. Thereafter, from pi over 4, I need to turn some more by pi over 5. And then this will be my eventual outcome or eventual position of my point Q. Okay, double the length of OP, add on pi over 5 into my angle.